The phrase polar vortex has become quite common in weather discussions, often associated with intense cold. But beyond the headlines, what exactly is this phenomenon, and why does it matter so much to our weather patterns?
It's a great question to start with. The polar vortex is essentially a circular band of powerful stratospheric winds that circles the Earth's polar regions. Its primary function is to contain very cold Arctic air. When this vortex is stable, that cold air stays locked up in the Arctic. However, when it's disrupted, it can have significant consequences for weather in mid-latitude areas like the US, Europe, and Asia, bringing that frigid air much further south.
So, the stability of this wind band is key. What causes it to become unstable or disrupted? It sounds like a pretty fundamental atmospheric feature.
So our planet's topography plays a direct role. What about broader climate trends? Does Arctic amplification, the rapid warming of the Arctic, also contribute to these disruptions?
It absolutely does. Arctic amplification is a phenomenon where the Arctic region warms at a much faster rate than the rest of the planet because of climate change. This warming leads to significant melting of Arctic sea ice. When that ice melts, it reduces the temperature difference or gradient between the pole and the equator. This weakened temperature gradient, in turn, weakens the polar vortex, making it far more vulnerable to disruption by those Rossby waves.
So climate change isn't just making the Arctic warmer, it's potentially altering fundamental atmospheric structures, leading to more extreme and less predictable winter weather in other parts of the world.
Yes, two other internal atmospheric phenomena are important. The Arctic oscillation, or AO, can enter a negative phase. When this happens, it weakens the jet stream, which is another crucial atmospheric current. A weaker jet stream allows the polar vortex to become wavier and shift southward. Then there's the quasi-biennial oscillation, or QBO, a band of tropical winds that can either strengthen or weaken the polar vortex, depending on its phase.
It sounds like a complex interplay of many factors. You mentioned topography earlier with Rossby waves. Does the Earth's geographical layout inherently make the northern hemisphere's polar vortex more prone to disruption than, say, the southern hemisphere's?
That's a keen observation. It does. The northern hemisphere has a much more diverse distribution of land masses and mountain ranges compared to the southern hemisphere, which is mostly ocean. This varied topography generates more atmospheric waves, making the northern hemisphere's polar vortex inherently more susceptible to disruption.
That makes sense. Beyond these persistent natural and climate-related influences, can sudden external events also trigger a disruption?
They can. Events like major volcanic eruptions, such as the Hunga eruption, can inject ash and gases high into the atmosphere, which can then influence the polar vortex's behavior. Similarly, variations in sea surface temperatures and different ocean basins around the world can also impact its stability.
Given all these potential causes for disruption, what are the primary consequences for us here in the mid-latitudes when the polar vortex does falter?
The most direct and noticeable consequence is severe cold air outbreaks. When the vortex is disrupted, that intensely cold Arctic air, which normally stays contained, can push much further south into populated mid-latitude regions, leading to significantly colder temperatures and often heavy snow. These disruptions can also cause broader shifts in weather patterns, resulting in other extreme weather events and unusual temperature fluctuations, not just extreme cold, in affected areas.
So understanding the polar vortex and its complex mechanics is vital, not just for scientific curiosity, but for predicting and preparing for the kind of extreme weather we're experiencing more frequently. It's a critical lens through which to view both natural variability and the impacts of climate change.
Precisely. The stability of the polar vortex is influenced by a combination of sudden stratospheric warming, Arctic amplification, and various atmospheric oscillations and external triggers. Recognizing these dynamics allows us to better anticipate and respond to global weather patterns and the broader effects of climate change.
If you found this discussion insightful, consider sharing it with someone who might also find it interesting.